So the next goal is to actually extract this dynamic path parameter value from the URL when that component here is loaded, so that we can get the actual user ID for which this component was loaded and use it inside of this component. And there are different ways of achieving this, and as an Angular developer, you should know about all these different ways, because chances are high that you'll see these different ways in different projects. Now, the easiest way of getting hold of such a path parameter value in a component that's loaded for a dynamic route is to add an input to that component that has the same name as your dynamic path parameter. So here I chose user ID written like this. Hence, I would add user ID written like this, so written in the same way, as an input, for example, with the input function to this user tasks component. And you could, of course, also use the input decorator instead. And I'll make this a required input and make it clear that it'll be a string, because these URL encoded values will always be strings, because the entire URL is one long string. Now, for this approach to work, we need to go to our application config though, because there you need to tell the Angular router that you want to use this input-based approach. And you do that by going to provide router, and then there, as a second argument, you pass the result of calling with component input binding, which is a function that must be imported from @AngularRouter. And this function will in the end create a configuration object, you could say, that's passed to provide router as a second argument, or as any argument as long as it's not the first one, because that must be the routes, that will tell Angular that you want to have this input binding approach enabled. With that configuration added here, you can go to your user tasks component TypeScript file, and there this user ID input will then be set by Angular. Therefore, we can now use this user ID here to retrieve the name of the user, because that is what I want to output here in the template of this component. Now, to get the username, I have this users service, which in the end is just a dummy wrapper around this dummy users array, which I have in a separate file. And of course, in a real app, you might be fetching that data from a backend, you might be sending an HTTP request there, but to keep things simple and focus on the routing in this application, I'm just using this dummy file and this dummy service that gives me the users from that file through a getter. So we need to inject this users service into this component here. Hence, I'll add a private property, users service, and I'll inject it with the inject function, as we did it many times before in this course. So of course, both the service and the inject function are imported. And then we can, for example, get our username here by setting up a computed property with the computed function, since I'm dealing with a signal here. And then here, we could use our users service, access the users, and find the user with a specific ID. Find, of course, will execute this function which we pass to it on every user in that users array. And we get that user as an input here. And I then want to return true if the ID of the user I'm currently looking at in this array is equal to this.userid. And we have to read this like this, since it's a signal. That will give me the entire user. Here I'm just interested in the name though, so I will call name on the result of calling find. Though this question mark here is needed, because find could of course yield undefined if we don't find a user for that ID. With that though, we can go back to the component, and instead of outputting users here as a placeholder, we can now output the user name like this, reading it as a signal since I'm dealing with signals in this application. But of course, just to be very clear about that, you could absolutely also build this application without signals. Routing does not require them. With that, however, if you save that, you should see the username being reflected here. And of course, as you switch between different users, that name changes. And that's therefore one way of extracting and using the data that is encoded in the URL when working with dynamic routes. It's, in my opinion, the most convenient way of doing that, but it's not the only way. So you can get hold of the dynamic path parameter values and extract them with help of inputs if you enable this with component input binding setting here when providing the router. Now, it is the approach I personally prefer because it is straightforward, but it's not the only way of getting hold of those path parameters. And especially if you would be working in an older Angular version, you might not have access to this approach. And therefore, it's also worth knowing about the alternative way of extracting that data. Now, an alternative way, which you might need to use because you can't use this input binding because you're using an older Angular version, or simply because you don't like it, an alternative way of getting hold of that dynamic path parameter value would be to inject a special kind of service into this component. And that would be the activated route service, activated route, which must be imported from @AngularRouter. And I'm storing it in a property named activated route here, though as so often the name doesn't matter here. Activated route then gives you various properties that hold information about the route that has been activated by the Angular router. And you can, for example, implement the onInit interface so that you're forced to add ngOnInit, so that in there you can console log this activated route so that you get an idea of what's inside this injected object. If I do that here and I then take a look at my console, I can see that activated route is an object that, for example, holds a pointer to the class, the component class that has been loaded. And then it holds a bunch of subjects, so a bunch of observables in the end that are managed by Angular. And it holds some additional properties which are in the end derived from these subjects, like param map, which would be an observable in the end to which you can subscribe to be notified about changes to the route parameters. You can also extract other information and we'll work with some of that data later in this section. For the moment, we could, for example, simply set up a subscription to param map here. And that will give us that param map here and pass an observer object to it and define that next function where we will get that param map. And that param map in the end is an object that will hold key value pairs where our dynamic path parameters, so these identifiers we defined during route setup, are the keys, and the actual values that are encoded in the URL are the value for those keys. So here we could then, for example, manage the username not as a computed signal like this, but instead we could set the username to an empty string initially. And then here in this next function, we could use the users service and access all the users there to find a user, just as we did it before. But now I want to compare the user ID of a user in that array to param map get user ID. Because this param map object has a get method that allows you to extract one of its key value pairs that's managed by it. And what you pass to get, of course, has been an identifier you specified when configuring the routes. So if you used user ID here after the colon, that's also what you want to get access to with get here. So that will then give you that user ID that's encoded in the URL, and that will therefore then find us such a user. Now, of course, I now want to update my username with the name of that user. So here in that next function, I actually want to set this username equal to this user's service users find, and then there I access the name. And now I'll just wrap that here with curly braces like this, and I'll add a fallback here to set the username to an empty string in case we don't find a user for that ID. And with that, we would have an alternative way of getting hold of that route param value. Of course, a more complex way than what we had before, as you can tell, but still an approach you could use. And you could, of course, also use this param map observable in other ways. You could set up a pipeline where you use observable operators to extract the username. This here is just one possible way of using it. Depending on your level of RxJS knowledge, you could also embrace RxJS more and find alternative solutions. One thing you should definitely do, though, is store the subscription and clean it up once you don't need it anymore. So you should inject that destroy ref thing, which we also used before in this course. And then here in ng-on-init, use this destroy ref on destroy hook to clean up that subscription whenever the component gets destroyed. You also might wonder why it's a subscription in the first place, but the reason simply is that Angular will reuse this component as you switch between different users and will not reload it all the time, because reusing it is more efficient. Therefore, the only thing that will change is that user ID that's encoded in the URL, and that's why this is a subscription, so that you're notified every time this user ID changes, and so that you can update any data that depends on it, like this username. With that, in the user tasks component HTML file, username is now no longer a signal, therefore I'll not execute it, but instead use it like this. And with that, if you save that, you should be able to switch between different users and still see their names here, but now with help of this param map and observables instead of relying on the input binding. By the way, since I'm logging the activated route here in ng-on-init, you can tell that this component is being reused, because if I reload, I got this log once, but as I then switch between users, I got no new logs. And yet the component is updated. So there is some reactivity, but this overall component here is clearly not replaced and re-rendered, because if it would be, then this log would be replicated, because ng-on-init would execute again. But that's not the case here, because this component gets reused. So that proves that point I made before.